This video is over chapter 33, absolute convergence. So I am assuming at this point that you have read definition 210 and definition 211 on what it means for a series to be absolutely convergent and conditionally convergent. This series is conditionally convergent. This is the alternating harmonic series, and you recall that the harmonic series is divergent. So if we were to take the absolute value of these terms, this series would diverge. But this series, as it is written, is convergent. Therefore, this series is what we call conditionally convergent. Let's look at the terms and see why. We have 1 minus 1/2 plus 1/3 minus 1/4 plus 1/5 minus 1/6, etc. Don't need to do that yet. So this is what the series looks like. Now, if we group the terms in pairs, like this, we see that what we have, we can write this as a series of positive terms. So we can write this as the series n equal 1 to infinity of 1 divided by n minus 1 divided by n plus 1. And we've looked at series like this before. This can be written as room. Let me write it over here. This is the sum. This is the sum of n equal 1 to infinity of, so here we get a common denominator, and we have 1 divided by n times n plus 1. We just add these two terms here. Now, since 1 divided by n times n plus 1 is less than or equal to 1 over n squared, and the sum of n equal 1 to infinity of 1 over n squared converges, the series n equal 1 to infinity of 1 divided by n times n plus 1 converges. It converges by the comparison test. But I'm out of room here, so I'm not going to write by the comparison test. I'll just write that it converges and say that it converges by the comparison test. So the alternating harmonic series converges. Now we look at this series. The difference here is we're going to learn in the next chapter what an alternating series is. This is an example of an alternating series because it goes back and forth, positive, negative, etc. This series does not necessarily do that. But remember that sine is bounded above by 1. Sine is bounded between -1 and 1. Since sine n divided by n squared an absolute value, since sine n divided by n squared is less than or equal to 1 over n squared, and this series converges because it is a p-series with p equal to 2. This series n equal 1 to infinity of sine n divided by n squared in absolute value converges. Therefore, the series that we were given, sine n divided by n, is absolutely convergent. I will write AC for absolutely convergent. That is all I wanted to say about this chapter. It's all I'm putting in the video.